So I have a lot of data here. Let me show you the data sheet. And we have a coffee shop, and the drinks are actually items and snacks. Let's say snacks, and slash items. Let's just keep it at drinks. Okay. What we have here is our items in our coffee shop. And this was the quantity sold and the advertising we did and the price per unit. So per unit of mocha vanilla. During a specific period of time, this is the quantity sold. It doesn't matter what the period of time is, probably 1 week or 1 month or something. What we want to know, well, first we're going to just do quantity sold and advertising and compare those two. So does advertising have an effect on quantity sold? That's what we want to know. And to do this, we call this regression. And what we have to do is, you know how to get the data analysis tab, I think. I already showed you that. And get the regression down here. And let's see, we want our labels and 95% confidence interval. New worksheet. Yeah, let's go new worksheet. This ought to do it. So what you got to do here, let me make this blank again. And what you have to do is, this is the y-axis here. So quantity sold is dependent upon advertising. That's the y-axis. So that's got to go here, y input range. And you should know what that is from your calculus or your algebra classes. Advertising. Okay, we're doing advertising. Later we can compare quantity sold and price and average age, and you can compare all these things. One, two, single variables or double variables or multiple variables. All right, so let's go ahead and click OK. And this is our results here. But actually, I've already did the results, and I have some notes. So let's look at these results. So first thing we want to look at is R square. So this means this 0.74, or you can say 75%. My change in items is explained 75% by advertising. So the change in our items sold is influenced 75% by our advertising. So advertising does have a strong influence, we think. Maybe not, but we need to look at our significance F to see how strong that relationship is. All right, so where's significance F? Okay, here it is in ANOVA. Oh, okay. Well, to show, stay there. To show strength in the relationship, this number should be, this number should be below 0.05. So obviously it's not, and it's pretty high. So our relationship between y and x is weak. This doesn't mean there's no relationship. There is a relationship, as we can see here, but our relationship is weak. So to actually explain significance F, we need to have a statistics class, and we don't really have enough time to explain the details and go into the formulas of this, but we will try to explain as best I can. Our coefficients. Okay, so this is our total revenue when y is equal at 0. So on the y-axis, when we go down to 0, this is our revenue. So this is our base revenues, you could say. And this, so far, every dollar we put in advertising, or renminbi, or whatever you want to call it, we are going to multiply by 1.2 in sales, which is not that much. And this is all we're going to look for right now. But here's the formula. the actual formula, so you can put for every x, you can put this x in there, and it's the intercept at 0 plus our advertising, um, and the x where the advertising is. Okay, the advertising x times 1, the coefficient of 1.22 will give us our predicted sales for that particular x based on the total regression of all of our numbers. Okay, good. And here's the predicted revenue. And when we do that, our predicted revenue, actually our predicted items sold. So every time you put a different number into advertising, you'll get a different number out here in different coefficients and different R squares. So this R square is more accurate than the multiple R up here. The R square is just the square root of this number right here. And that's it so far for this regression. You know, if your boss or anyone gives you, your manager gives you a bunch of data and they say, well, give me a prediction. Well, you can do that using this tool up here, this data analysis regression tool.